Welcome back to Mech 232 Automated Systems. Today we're diving into TCP calibration, covering tool center point teaching, offset calculation, and motion verification. Let's start by meeting our robot again. This is Barry, our Omron TM14 collaborative robot. Barry is going to help us look at how to teach a 4-point tool center point, save active tool data in TM flow, and demonstrate tool coordinate motion. Let's begin. Let's break down what a tool center point, or TCP, actually is and how it works. By default, a robot arm only knows where the center of its bare mounting flange is. It has no idea what tool you bolt onto it. Since Barry is holding an on-robot gripper with a custom 3D printed pointer, the actual spot where the work happens is way out at the tip. Defining a TCP tells the robot controller the exact distance from its bare wrist out to the tip of our pointer, so it moves and rotates around the tip instead of its flange on the wrist. To set up this Omron TM14 using TM Flow, we navigate to the tool setting menu on our monitor, create a new tool profile, and enter our tool's weight of 1.3 kilograms. We select the 4-point calibration option. Now, to do a calibration, you need a fixed calibration reference point. In our video, that's the black reference cone taped down to the workbench. The reason this exists is because the robot controller needs a single, perfectly stationary target in the physical world to measure against. By keeping the target completely still, the robot knows that any change in number comes from moving the arm and not the target. Using manual jogging controls on the screen and keyboard, we carefully jog the robot to bring the tip of our 3D printed pointer into close but not direct contact with the sharp tip of that fixed reference cone. Notice that we don't record the exact same angle 4 times. We touch that same reference tip from 4 drastically different approach angles: tilted left, pitched forward, and coming in from different sides. Here's why. If you come in from the exact same angle every time, the robot can't figure out how long or crooked the tool is. By touching the exact same fixed reference point from multiple different angles, the robot calculates where all those angles cross paths in 3D space. The only single point shared by all 4 positions is the very tip of our tool. If our angles were too close to each other, the robot would just end up guessing and giving us a bad calibration. Once all 4 points are recorded, TM Flow gives us our final offsets: X at 3.3 mm, Y at -24.99 mm, and Z at 350.91 mm. That Z number simply means our tool extends 351 mm straight out from the robot wrist flange. Our residual error came out to 0.31 mm, which is essentially the robot telling us our 4 manual touches were spot on. Finally, we save and activate this TCP. Just like we showed in Lab 1, switching to tool mode lets us rotate the robot around our new tool tip. As you can see in the video, when we rotate the arm, the tip stays locked right on top of the reference point without swinging around in a big circle. The TCP is saved, verified, and ready to go.